Hi everyone. So this is the video of continuous video from our previous lecture, which is presenting data in numerical way. So the previous video, we have learned about how to present our data in numerical way, which is in measure of central tendency, or what we call as measure of location and measure of shape. So measure of central tendency, we learn about mean, median, and mode. And measure of shape, we have learned about normal distribution, skewedness, which is skewed to the right and skewed to the left. So for this video, we will learn about measure of variability. All right, measure of variability, or we call it as measure of dispersion. So in this lecture, we will learn 5 new measures, which is consists of range, interquartile range, variance, standard deviation, and coefficient of variation. So what is measure of variation? So measure of variation give information on the spread or variability of the data value. So in Bahasa Melayu, we know it as pengukuran data keteraboran. Okay, keteraboran data. So here, for example, determine the mean marks for each of the subject. So if you look here, we have 3 subjects: business study, economics, and geography. So how many students we have? A, B, D, E, F, G, H, I, J, K. We have 10 students here, all right? We have 10 students. So each of the students, they have marks for business study, economics, and geography. So this is example of raw data, okay? Example of raw data. So from that raw data, we can come out with a bar graph. Okay, we can come out with a bar graph. So mean gives no indication on the distribution of the mark within the sets of figures. Meaning to say, mean does not shows the distribution of the marks. Keteraboran data ni tidak ditentukan oleh mean. So if you look at this graph, which 2 graphs looks alike in terms of mark distribution among the 10 students? So it's very hard for us to identify. Okay, very hard for us to identify. I don't think there's 2 similar graph or 2 similar distribution among the 3 subject. Okay, so on this measure of variation, the question that we always ask is how widely dispersed is the data, and how are there a lot of different values, or are many of the values the same? What value is in the middle of the data? Where does a particular data value stand with the respect with the other values in the data set? So this is about how widely the data is spread. Okay. For example here, okay, for example, why we need measure of variation. If you look at data A, data B, and data C, the 3 datas are very different. Okay, very different. But the 3 data set, the mean is equal. Okay, the mean is equal. If you look at the mean is 15.5 for the 3 data set. So how to calculate mean is easy. 11, like for example, data A set data A, 11 plus 12 plus 13 plus 5, sorry, 11 plus 12 plus 13 plus 16 plus 16 plus 17 plus 17 plus 21 divided by 8. Okay, divided by 8 will give 15.5. Data B, 14 plus 15 plus 15 plus 15 plus 16 plus 16 plus 16 plus 17 divided by 8. So it will give 15.5. Same goes to C, plus all the values and divided by 8. So it will give the same answer, 15.5. So how to measure the differences between data A, data B, and set data C? So in this case, we need to have measure of variation. So in this example, we use standard deviation. The S value here is standard deviation. All right. The S value here is the symbol for standard deviation. So if you look, the mean is somewhere here. Okay, 15.5, 15.5, 15.5. So standard deviation, how it works, standard deviation will calculate the distance between one value to the mean. Okay, meaning to say how far is value 11 to 15, how far value 21 to 15, how far value 18 to 15, how far 17 to 15. After taking overall weightage of the distance between a value and the mean, it will give the value of standard deviation. If you look at data B score the lowest standard deviation. Lower standard deviation means most of the data is very close to the mean. Okay, I repeat, if most of the data is close to the mean, so meaning to say the standard deviation will be lower. Okay, the standard deviation will be lower. So if the data is spread very wide, okay, berjauhan daripada mean. If the value in the data is far from the mean, the weightage of the standard deviation will be higher. Okay, will be higher. So dispersion. So if you look at the three data sets, in all the sets, the numerical value of the mean is 15.5. Okay, 15.5. Still, the three sets are so different. The observation values in data A and C are so different. We need another measure to describe the dispersion or the spread of the data. So dispersion tells the extent to which observation vary amongst themselves. A measure of dispersion, such as variance and standard deviation, is designed to state numerically the extent to which individual observations vary on the average. So the first one, range. Range is the most simplest measure of variation. I think this is not a new thing for you, very easy. So range here, the formula will be largest value minus lowest value. Largest value here, for example, here down. So largest value here is 14. Smallest value is 1. Okay, so 14 minus 1. Your range will be 13. So range here will only indicates the two value. Okay, only indicates the two value, the highest value and the lowest value. Disadvantage of range. Okay, range ignore the way in which data are distributed because range only took the highest value and the lowest value into consideration. The rest of the data range will ignore. Okay, that's why range ignore how the data are distributed. For example, here, if you look the first one, 12 minus 7 equals to 5. For the second dot plot, The distribution is different, but still the range gives the same answer. 12 minus 7 equals to 5. This is the disadvantage of range. Second one, range is very sensitive to outliers. Outliers here is extreme value. So if your data set has extreme value, your range will be large because of the effect atau because of the impact of the outliers. Example here, 1, 1, 1, 1 until 2, 3, 5. So 5 is the largest value and 1 is the smallest value. So 5 minus 1 is 4. Now we change 5 to 120. So 120 is outliers, extreme value. So 120 minus 1 will be 119. So the range will be very high because of one single digit, which is the outliers. So range sometimes is appropriate to be used and sometimes it is not appropriate to be used. But this is the most simplest way in measure of variation. Second one will be interquartile range. Interquartile range, it is a bit different from range. Okay, so let's look at this. So interquartile range here is the range of middlemost 50. Okay, middlemost 50. Middlemost 50 here means that it will take the range in the middle 50 only. Okay, middle 50 only. So interquartile range, some range value, but they have very different distribution. So also to avoid extreme observation, interquartile range is useful as a measure of dispersion. A large interquartile range value indicates data are well spread. Maksudnya, if you have large interquartile range value, the data is widely spread. If your interquartile range is low, mean to say your data is more narrow or more closer to the median. Okay. After this, I will show you the example. And using interquartile range, we can identify the outliers. So the formula of identifying the outliers is this. So this is the formula to identifying the outliers. Okay. So how to identify? So this is the formula. So in interquartile range, we will have Q1, which is what we call quartile 1, Q2, quartile 2, and we have Q3, quartile 3. So how it works, for example, okay, for example, this is interquartile range, interquartile range. So I draw a box plot. This is what we call box plot. Okay, and we have the whisker. Okay, we have the whisker. So this is Q1. This is your Q2, and this is your Q3. Okay, so and here it will be the lowest value and the highest value. Okay, so this is example of data set when we arrange in ascending order. Okay, ascending order meaning to say from lowest to highest. Okay, we need to arrange our data in ascending order. So from lower value to the quartile 1 is 25% of the data. So if your respondent is 100, there is 25 respondents data between lowest value to quartile 1. To quartile 2, to quartile 1 to quartile 2 is another 25%. Quartile 2 to quartile 3 is 25%, and quartile 3 to highest value is another 25%. So the total here will be 100% of your data. Okay, percent here is the proportion. If you have 100 respondents, so 100 respondent, 25 respondent is between lowest value to the quartile 1. Then another 25 respondent between quartile 1 to quartile 2. If your total respondent is 200, so lowest value to quartile 1, you have 50 respondent. Quartile 1 to quartile 2, you have another 50 respondent. And quartile 2 to quartile 3, you have another 50 respondent. So it depends how many is your sample size. Okay, what is your sample size? So this is interquartile range. So interquartile range, the formula is equals to Q3 minus Q1. This is the formula for interquartile range, meaning to say it's only take the middle 50 here. Okay, this is interquartile range. Okay, middlemost 50% only. Okay, so interquartile range will try to avoid outliers. Okay, because outliers usually is somewhere here. Here can we have the outliers. Here we can have our outliers. Okay, how to determine is outliers or not outliers? So you look at our formula just now. Okay, our formula here, the lowest value will be Q1 minus 1.5 times interquartile range. So this point will be Q1 minus 1.5 times interquartile range. Okay, this is the point. And this point will be Q3 minus 1.5 times interquartile range. So whatever value, okay, whatever value more than here, less than this value or more than this value, calculated value, your value is considered as outliers. Okay, that will be in the outliers region. After this, we do a calculation. Okay, we will do a calculation. So this is a format for or how we are calculating interquartile range. Okay, interquartile range and determine the outliers. Okay, we determine the outliers. Okay. So values which are smaller than the lowest value or largest value in the box plot are known as extreme value outliers. So example here. A recent study was conducted to compare the age of the vehicle in the student's parking lot versus those in the faculty parking lot at a major university. So a random sample of 15 cars was taken from each lot and the age of the car was recorded by taking the current year and subtracting the model year from it. So the below are the two box and whisker plots summarize this result. So this is the faculty car and this is the students. Okay, and this is the age of the car, y and x here. Okay, so if you look, we have one dot here. This is what we call outliers. Okay, extreme value because it's outside the whisker. Okay, it's outside the whisker. So from here, this is Q1, this is Q2, and this is Q3. This is Q1, Q2, and Q3. Okay, so if you look, Q1 to Q2 and Q2 to Q3 has the same value. Okay, the distance is same. Same goes to here. So this is all. This is we can consider as normal distribution. Okay, normal distribution. But here Q1 and Q2 is closer compared to Q2 to Q3, which is more further. All right. So if you do this, it's more like a either skew to the right. It's a skewness distribution. Okay, it's a skewness distribution. So this is what we can report. Okay, this is what we can report. Overall, the faculty are newer with the median age of 3 years compared to the median of 6. So if you look here, sorry, this is 2. Okay, 2. So if you look here, Q2 is always the median. Okay, because Q2, this is Q2, Q2 to lowest value and Q2 to the highest value. This is okay. This is 50%. Okay, lowest value to Q2 50%, Q2 to highest value is another 50%. That's why this can be considered as median. Okay, Q2 is the median. Okay, Q2 is the median. Okay, so if you look, median for the faculty staff, okay, is 2. Okay, 2. But for students car is 6. It's 6. So overall, the faculty car are newer with the median age of 2 years compared to the median age of 6 years for students car. There was at least one faculty car that was much older than the rest, that shows as outliers as 7 years. Okay, this is the outlier, 7 years. The overall range of the age of the students' car, the staff car that they are, sorry, faculty car is larger. Okay, 10 minus 1. Okay, yes, as compared to the range of the age of the car owned by the faculty is 7 minus 1. Sorry, it's students, betul. Students car here 10 minus 1. Okay, and the faculty is 7 minus 0. So different is 7 here. 10 minus 1 is 9. So this is the difference of the range. So the faculty on car is more newer compared to the student's car. So this is how you can interpret your interquartile range. Okay, how you interpret your interquartile range. Another example here. Variable CD. Okay, so N, capital N, sample size, sorry, population size. Then this is the population mean, 85. Minimum is the lowest value. Q1 is 30. Median, or what we known as Q2, is 50. Q3 is 100. And the maximum highest value is 500. So the first question here, what percent of students earn somewhere between 30 to 50 CTR here? 30 to 50. So the answer is 25 because it is difference between Q1 and Q2. Okay, Q1 and Q2. If you look here, from Q1 to Q2 is 25%. Okay, 25%. So if I draw, okay, if I draw here, lowest value, okay, lowest value, berapa lowest value? 0. Then we have our Q1 30, Q2 50, our median, Q3 100, and we have our highest value 500. Jauh, right? So from here, the question just now is asking for Q1 and Q2. So this is 25%. From lowest value to the Q1 is 25%, and Q2 25%, and this one 25%. Okay, so this is how it works. If I draw a box plot, it will be something like this. Later on, we draw the whisker. Okay, we draw the whisker. So the answer is B. Okay, the answer is B. Okay, second one. Based on the summary shown, which of the following statement most likely describe the shape of the distribution? So we are now looking at measure of the skewness ataupun measure of the shape CD on database. So the summary is the evidence that the data are symmetric and bell-shaped. The summary is evidence that data are symmetric but not bell-shaped. C, the summary is evidence that the data is skewness to the left, or D, skewness to the right. Let's look at the example. So if you remember the video, our video in the previous video, we learn about how to determine the skewness of the histogram or the line. So if your mean equals to median, this is normal distribution. Okay, it's normal. Wait, I proceed with a new. Okay, mean equals to median. No, normal distribution. If mean more than median, is skew to the right, because the mean is on the right of median. If the mean is less than median, so it's skew to the left. All right, so we check our name. So our median is 50, mean is 85. Okay, mean is 85. So in this case, our mean is 85, median is 50. So mean is more than median. Okay, the mean is more than median, so it's skew to the right. Okay, it's skew to the right. So the answer will be D. Okay, will be D. Okay, I just have another questions from this example. We can try to look at, is zero is outliers or not. Okay, we want to check whether zero is outliers or not. So how to check will be, we need to check what is our whisker, lower whisker here. So the formula will be Q3, Q1 minus 1.5 times interquartile range. So Q1 is 30 minus 1.5 times interquartile range will be, I put it here, interquartile range will be 100. Okay, Q3 kan, Q3 minus Q1. So 100 minus 30, okay, equals to 70. So times 70. So equals to 330 minus 1.5 times 30 is 105, correct? 105. So 30 minus 105 will be negative 75. So this whisker is actually less. Dia sampai sini. Negative 75. Okay, negative 75. So 0 is not outliers. Okay, 0 is not outliers because the whisker is under negative 75. Okay, let's check our upper whisker. Okay, so Q3 plus Q3 plus 1.5 times interquartile range. So Q3 is 100 plus 1.5 times 70. Okay, sudah kita kira tadi 70 equals to 100 plus 105 equals to 205. Here is 205. So the upper whisker is 205. In this case, highest value is outliers. Okay, it's a outlier. So this is how you identify outliers in a data set. Okay, this is how you identify outliers in a data set. Okay, next question. Okay, outliers is a data value that is larger than 1 million, not necessary. Equals to the minimum value in the data set, not necessary. Equals to the maximum value in the data set, not necessary. It is not consistent with the bulk of the data. So the answer is D. Okay, D is the answer. Which of the following statistic is unaffected by outliers? Okay, unaffected by outliers. Just now, in the previous video, for mean is affected by outliers. Median is not affected by outliers. Range is affected by outliers. Interquartile range is not affected by outliers because interquartile range will take the middle part only. Okay, interquartile range is Q3 minus Q1. Nothing to do on the 25% on the left and another 25% of the data on the right. So interquartile range avoid calculating outliers. Okay, it avoids calculating outliers. So the answer is A. Okay, A. Okay, which of the following would indicates that a data set is skewed to the right? Like I have mentioned just now, data set skewed to the right, mean is larger than median. Okay, mean is larger than median. So the answer will be C. Okay, the answer will be C. Okay, next, variance and standard deviation. Okay, variance and standard deviation. So this is the most frequently used measure of dispersion. So variance and standard deviation are a measure on how widely values are dispersed from the mean value. So variance is defined as the mean of square deviation observation from the mean, and standard deviation is a square root of variance. So variance has a unit that is different from measure of central tendency. So for example, mean age 25.5 years, but variance is 8.67. So mean here is looking at the location of the data set, meaning if you have a lot of data set, mean will represent all the data as one value. But variance here is to show the spread of the data. Okay, it's to show the spread of the data. So more practical to use the same unit of measure of central tendency and dispersion. So if you write in your report, it is a good practice for you if you provide these two information so that the reader or those who evaluate your report, they understand on what you're trying to explain. Okay, so it is good for you to relate these two. So range, interquartile range, and standard deviation. So only standard deviation takes all the data values into account. However, this leaves it open to the problem similar to the mean, a tendency to swerve inordinately by extreme value. So standard deviation like mean calculate or use all the values in the data set in calculation. Okay, that's why if there is an outliers, the standard deviation will be affected. Right? Standard deviation will be affected. Same goes to mean. The range is extremely sensitive to outliers. Okay, because range is only taking highest value and lowest value. Standard deviation is taking all the values in the data set. But if there's an outlier, still open to disadvantage. Since it is based on the smallest and the largest value. So the interquartile range is again based on two values, the upper and the lower quartile. These are on each end of the middle half of the data, therefore less affected or not affected at all by the outliers or the extreme value. This is the formula for population variance. Hi, sorry for the technical problem. So I repeat back. So difference between range, interquartile range, and standard deviation. Only standard deviation takes all the data value into account. However, it leads to open the problem similar to the mean. effect by the outliers or effect by the extreme value. The range is extremely sensitive to outliers since it is based on the smallest and the largest value. And interquartile range is again based on only two values, the upper and the lower quartiles. These are on each end of the middle half of the data, therefore less affected by extremes or the outliers. Or usually it is not affected by outliers. So this is the formula for population variance. There is sum here, sum of x. Sorry again for the technical problem. So my iPad refused to show all the symbol from because I'm changing from Microsoft to iPad. So this is the formula for population variance for ungrouped data. So if you look at here, this is the what we call sigma square. Okay, sigma square equals to sum in bracket of x is the value minus population mean. Okay, this is mu, population mean in bracket. You need to square divided by n. N here is a capital N. Later on, I will share with you a more simple formula that you can use for your calculation. Okay, this is one of the formula. For sample variance, this is variance, so equals to sum. This is the sum in bracket x minus x is the value minus sample mean. X bar is the sample mean. Close bracket divided by n minus 1. So the difference between population, n is not minus 1. But for sample variance, n is minus 1. Okay, divided by n minus 1. So this is the formula for population standard deviation. Population standard deviation. So population standard deviation is most commonly used measure of variation. Shows variation about the mean, has the same unit as the original data. And this is the sample standard deviation. Okay, beza dia, okay, the difference between sample standard deviation or the difference between variance and standard deviation. If you look at the sample variance, S square is the symbol. For sample standard deviation is only S. And the formula, if you square root it, if you square root the formula, so it will give the sample standard deviation formula. It's actually the same formula, but different usage. So usually we calculate sample standard deviation. Okay, we calculate sample standard deviation. This is an example how to calculate sample standard deviation. So if you look at the data, we have 10, 12, 14, 15, 17, 18, 18, 24. This is a raw data. So first, we need to calculate our mean. Okay, must calculate our mean. So 10 plus 12 plus 14 plus 15 plus 17 plus 18 plus 18 plus 24 equals, after you total everything, divide by 8, the answer will be 16. Okay, will be 16. So from here, then you calculate your sample standard deviation. So 10 is the x, okay, x just now, this x is the value. So x minus 16 plus 12 minus 16 square plus 14 minus 16 plus 15 minus 16 square plus 17 minus 16 square. So need to do for all the values until 24 minus 16 square. So one by one. So this is to look how far is a value compared to the mean. Okay, berapa jauh nilai dalam data set tersebut berbanding mean data tersebut. Okay, so after calculate and everything, so divide by n minus 1 because this is sample size is 8, 8 minus 1 is 7. So after calculate is 126. So 126 divide by 7, then you need to square root the answer, punca kuasa 2. So the answer will be 4.2426. So 4.2426 is the measure of the average scattered around the mean. Okay, so that is the value of the dispersion. Okay, value of the dispersion. Example here. The following data shows the daily profit made by a shopkeeper on 7 successive days. So we have 7 data here. This is a sample. 7 data. So 116, 87, 91, 81, 98, 102, 100. If you look at the formula, okay, this is the formula of standard deviation and this is how it calculates using that formula. But for me, I prefer one formula which is easier for me to use. Okay, this it's different formula but will give the same answer. Okay, give the same answer. So maybe you can look at this. Okay, so before I proceed with the calculation, I want to show you the formula that I have that I want to share. Okay. So this is the formula. So formula here, maybe you can write in your notes. So if you look at the formula, mean, raw, frequency table, and group data. Meaning say we have 3 types of how the data are given in equations. Like just now, is in the raw form. Sometimes it will be in frequency table. And sometimes it can be a group data. Okay, a group data. So to calculate mean, population mean, this is mu equals to sum of X. Okay, jumlah semua nilai dibahagi dengan jumlah populasi. Okay, total all the value divided by total population. For frequency table, mu equals to sum of frequency times all the value. Okay, we need to times all the value, all right? Because this is not raw data anymore. This is in the table form divided by population size. After this, there will be a example to use all this formula. Okay, ada latihan untuk kita akan buat untuk menggunakan semua formula ni. Group data mu equals to sum of FM. M is the midpoint. So each of the group in the group data, you need to calculate the midpoint. Okay, then you times with your frequency and divided by population size. Same goes to sample. Okay, sample dia N ni saja berbeza, sama saja. Okay, sama. For standard deviation, this is the formula. Okay, sorry, handwriting is a bit mess, but I hope you can look at this. So same, ada 3 types of data can be given in the questions. It can be raw data in the form of frequency table or group data. Okay, so population for population standard deviation. So equals to sum of x square minus sum of x in bracket square divided by n divide by n lagi. Untuk sampel sama juga, cuma is divided by n minus 1. okay, divided by n minus 1. Same goes to frequency table. You need to have your f. F is the frequency. So sum of frequency times x. So all the x you must square it first. Okay? After this, I will show you how to calculate. Minus sum of frequency times x in the bracket square divided by n and divide by n. Then you square root the answer. You will get population standard deviation. Difference to sample n minus 1. Okay, divided by n minus 1. Then overall divided by n minus 1. Then square root the answer. So group data x2 you change to m, midpoint. Okay, change to midpoint. Same goes to sample. Okay, same goes to sample. So this is the question just now. Okay, 16, 87, 92, 81, 91, 81, 98, 102, and 100. So these are all raw data, okay, X. So the question here, determine the range, the mean, and the standard deviation of the data. Okay, let's try to do. Kita sama-sama buat. Cuba buat juga di sana. Okay, so the formula just now, first we need to calculate our range. Okay, kita perlu kira range. Range. Okay, range easy. Paling senang adalah range. Highest value minus lowest value. So here, highest value is 116. 116 minus lowest value will be 81. Berapa? 35. Okay, 35 the answer. Second question is to calculate the mean. Okay, mean. Mean equals to formula ni raw data. So sum of x divided by n. Okay, so you need to total up your x. Berapa total? Total will be 116 plus 87 plus 91 plus 81 plus 98 plus 102 plus 100. It will give 675. So 675 divided by 7. Okay, ada 7 data. So 7 divide equals to 96.43. Okay, 96.43. This is how you calculate your range and mean. Then saya padam range. The third one, standard deviation. Standard deviation or symbol is S. Sample standard deviation equals to sum of x square minus sum of x in bracket square minus n divided by n minus 1. Okay, use this formula will be more easier lah. Okay, so we need to calculate our x square. Okay, calculate our x square. So 116 times 116 is 13456. Then 7 and 7569 8281 6561 9604 10404, and this will be 10,000. Okay, so this is your x2. Okay, x2 ni x square, sorry, x square. You need to sum it. Okay, jumlahkan. The sum will be 13456 plus 7569 plus 8281 plus 6561 plus 9604 plus 10404 plus 10,000. It will be 65875. Okay, so saya padam min ya. Jawapan akhir kita simpan. So equals to, now we have the answer here, right? So 65875 minus in bracket 675 square divide by 7. Divide by 7 minus what? Square root. Okay. So 675 times 675 is, so we do 675 square first. 675 square is 455625. Divide by 7. Okay, divide by 7 is equals to 65875 minus 65089. Okay, so 65875 minus 65089 equals to 6. 7 tolak 1, 6. 7 minus 1 is 6. So equals will be 786 divided by 6 square. So by so equals to square 131 equals to 11.45. So this is your answer for standard deviation. Okay, this is the answer for standard deviation. So I hope you can follow this formula. After this, we may try another question. All right. Okay. Okay, there's another question here. Find the standard deviation of the following number at 10, 16. Okay, you may try. Okay, cuba buat. Saya akan proceed dengan soalan yang lebih susah. So advantage of variance and standard deviation. Each value in this data set is used in the calculation. Okay, all the data are taken into account. So value far from the mean are given extra weight. If the value is far from the mean, the value of calculation will be bigger, okay, will be larger. So meaning to say it will give an extra weight. So when it is extra weight, your standard deviation value at the end of the calculation will be higher, okay, lebih tinggi. Pengiraan akan lebih tinggi. So this is an example of frequency distribution table. So if you look at this table, number of car on is the variable. The data is 0, 1, 2, 3, 4, 5, 6. That is the data. Okay. And number of household is the frequency. So don't get confused. So the sample size is 70. 70 tu adalah sample size. So the question is asking for mean, median, and mode. Find the mean, median, and mode. Then find the range and standard deviation. Okay. So how should we do? Okay, kita buat satu persatu. Okay, so if you look here, this is from the table. So find the mean. Find the mean. So mean, formula for mean is, because this is in the group form, kalau saya nak tunjuk, so we need to use this one. Okay, mean, mean equals to sum of fx divided by n. But this is population. Kita guna smaller n. Sama aja. Okay. So this is f. So kita perlu tambah because sum of fx divided by n. So we need to have fx. So 0 times 7 is 0. 1 times 25 is 25. 2 times 15, 30. 3 times 10 is 30. 4 times 10 is 40. 5 times 3 is 15. So you need to total it up. So 0 plus 25 plus 30 plus 30 plus 40 plus 15. The answer is 140. So 140 divided by n is the sum of frequency, jumlah frequency, 70. So the answer will be 2. Okay, mean is 2. Next, what is the median? Okay, before you calculate your median, you need to know the position of the median. Okay, the position of the median. So how should we do will be position of the median equals to n plus 1 divided by 2. Refer to the previous video. So 70, n is the total frequency, 70 sample size, plus 1 divided by 2 will be 71 divided by 2 is 35.5. So it's between 35 and 36. Okay, between 35 and 36. So how should we do? Okay, so if you look here, we have our household. Okay, our frequency, the second column ni frequency. So I want to reduce, saya kurangkan ni. So this is our F tadi, our frequency, household. So it's better if we can calculate our cumulative frequency. Okay, cumulative frequency. Cumulative frequency here will be, first one is 7. 7 plus 25 will be 32. 32 plus 15 will be 47. 47 plus 10 will be 57. 57 plus 10 is 67. 67 plus 3 will be 70. Sama, dia akan jadi sama. So here the position is between 35 and 36. 35 and 36. So position here in this here is from 1 to 7. Okay, the position. If we arrange in ascending order. Okay, if we arrange in ascending order, 1 until 7. Then here is 8 until 32, 33 until 47, 48 until 57, 58 until 67, 68 until 70. Okay, so the position we are looking at is 35 and 36. So 35 and 36 falls under here. Okay, because this is the position between 35 to 47. So the median will be 2. Okay, the median will be 2. Do not answer 47 or 15. Itu adalah frekuensi dan cumulative frequency. Median mean should be the data. Okay, the data. So mean here cannot be more than 5 because dia adalah 5. Paling besar. Okay, the largest number is 5. Okay, this is how we calculate our mean and identifying our median. Next will be mode. Okay, mode. Saya guna hijau, mode. Okay, mode here, highest frequency. Okay, highest frequency. Look, check here. Highest frequency will be 25. So mode is 1. Mode is the easiest. Okay, paling senang is mode. Okay, simple lah. I hope you get it. Okay, next. Calculate the range. Saya padam ni semua. Saya padam. Okay, range. Remember, this is our variable. If this is the question, this is our data. Okay, data. This is our data. So range, highest number and lowest value. So 5 minus 0 equals to 5. That is our range. Mudah sahaja. Okay, the last one, calculate our standard deviation. Okay, calculate the standard deviation. So standard deviation for sample equals to sum of, because this is in the form of frequency distribution table. So fx square minus in the bracket of fx square divided by n minus 1 square root. So here we need to calculate our x square. Kita perlu kira x square. Sebab kita kekurangan tempat, I just use somewhere here. Okay. Okay. So this is our x just now. So we need to calculate our x square. Okay, kita perlu kira x square. So x square here 0, x kuasa 2, 0, here 1, 4, 9, 16, 25. Okay. Then we need to times our f. Kita perlu times our f. So I do it here. Saya buat di sini fx square. Sorry So fx square 7 darab kosong. Kosong. 25 times 1. 25. 15 times 4. 90. 10 times 9. 90. 16 times 10. 160. 25 times 3. 75. And you need to total it up. Berapa total? So 0 plus 25 plus 90 plus 90 plus 160 plus 75. 440. So equals to 440 minus in bracket 140 ya, kita dah kira ni 140 square n kita adalah total frequency ni. So 70 divide by 70 minus 1 square. So 140 square will be 19,600 divided by 70, so 280. So 440 minus 280 divided by 69. So 440 minus 280 will be 160 divided by 69. So we will give 2.32. Then you square it, the answer will be 1.52. So this is your answer for standard deviation. Okay, answer for standard deviation. Okay, so we have done these questions. Here you have done these questions. So another one. The number of times that students in a class fell ill last year is given in the table below. So 0, 1, 2, 3. Okay, this one I want you to try and do. Okay, we will discuss in our class later on. So the number of times that students in the class fell ill last year is given in the table below. So number of time is the variable. Okay, so 0, 1, 2, 3 is the data. Number of students is the frequency. So you need to find the mean and the standard deviation. Okay, you need to find the mean and the standard deviation. So I will ask you later on. All right, you need to try to do these questions. Next, group data. Okay, group data. So group data is different from frequency distribution table or the raw data. Group data here usually in the form of interval dalam bentuk class. Okay, class. So this if you look at the same formula here, this is the formula for sample mean. It's better for you to use the formula that I have shown to you. It's the same. Okay, it's the same formula. And this is the formula to calculate sample and population variance. Okay, sample and population variance. The formula that I have shown to you using my iPad just now, that I share with you, the iPad, is the down one. Okay, yang di bawah ni. Okay, just now the calculation that I use also is the formula here. Okay, but this is for variance. For standard deviation, you just add in square root. Okay, add in square root. All the square here in the front, you throw it off because you square this is square kan? So when you square root it, you throw away the square. Okay, kamu delete. So table below shows the expenditure of the family in a housing estate. So find the mean expenditure of the family. So how to do it? Okay, kita buat sama-sama. Kamu cuba you try to understand the calculation. Okay. Okay, so expenditure, number of family. So the question is find the mean. Mean here is equals to sum of, because this is a group data, frequency times midpoint divided by n. N is the total frequency. Okay, total frequency. So in this case, you need to calculate the midpoint. midpoint. Midpoint here will be 500 plus 0 divided by 2. Okay, so, sorry. Alah. So this is the midpoint. Okay, midpoint. 500 plus 0 divided by 2 is 250. Then 500 plus 1000 divided by 2 is 750. Then 1000 plus 1005 divided by 2 is 1250. Okay, 1250. Then 1500 plus 2000 divided by 2 is 1750. So this is the midpoint you need to calculate. So from the question, the frequency for the first class is 40. Then second class is 60, 15, and 25. Okay, 25. So you need to insert in the formula. So here you have your FM, frequency times midpoint. So you need to do frequency times midpoint. So 250 plus 40. Sorry, 250 times 40. Okay, darab 10,000. Then 750 times 60 will give 45,000. Then 1,250 times 15 will be 18,750. And 1,750 times 25 will be 43,750. Because you have the sum here, you need to total. Okay, you need to total plus 18750 plus 45000 plus 10,000. So 11,700 and sorry 1,17,500. Okay, so 117,500 divide by n. This is your n. Okay, n, sum of frequency. Your sum of frequency will be 140. 40 plus 60 plus 15 plus 25. So 140 divided by 140. So 117,500 divided by 140. So your answer will be 839.29. So this is your mean. Okay, this is your mean expenditure. Okay, so this is how you calculate. Okay, another example here, how to calculate standard deviation. So if you look here, ang pao received is the variable and all the data is in the form of class or in the form of group. So you group it, group. So number of children is the frequency, right? 2, 10, 5, 3, and then total frequency is 20. So midpoint 15, midpoint here will be 10 plus 20 divided by 2, 15. 10 plus 30 divided by 2, 25. 10 plus 40 divided by 2, 35. 10 plus 50 divided by 2, 45. Then your formula, okay, the formula will be similar like what I have shown you. Sum of Fm. Okay, just now is X, now become M. Okay, to guna M. So because we have M square, okay, so midpoint you need to square it. So 15 square will be 225. 25 square will be 625. 35 square will be 1,225. 45 square will be 2,025. Then in your formula, we'll have also frequency times midpoint. Okay, frequency times midpoint is to calculate our mean also. Okay, untuk pengiraan mean. So 2 times 15, 30. 10 times 25, 250. 5 times 35 will be 175. 3 times 45 will be 135. So the total will be 590. Then you need to calculate your FM square. So frequency times your midpoint square. So 2 times 225 will be 450. 10 times 625 will be 6,250. 5 times 1,225 will give 6,125. 3 times 2,025 will be 6,075. Then you total it up. After you total, will give 18,900. So for your mean will be sum of Fm. Okay, sum of Fm divided by sum of F, your sample size. So 590 divided by 20. So it will give 29.5. That is your mean. For variance will be, variance is without square root. Okay, tengok tidak ada punca kuasa, without square root. So the formula is sum of Fm square. Yang ini, okay, kolom terakhir 18,900 minus sum of Fm in the bracket square, sebab tu dia 550 times 550 divided by n. Ni 20. Ni and divided by n minus 1. 20 minus 1 is 19. So after calculation, you will get 78.68. So this is variant. That's why they got square. Then standard deviation, you need to square root the variance. Okay, square root the variance, it will give you the answer for standard deviation. So after you square root 78.68, your answer will be 8.87. So the amount of ang pao received by the children is divide as much as 8.87. Okay, so the keteraboran data tu, okay, the dispersion of the data is 8.87 from it means of 29.5. So this is another example. Okay, compute the mean and the standard deviation of the midterm exam marks for a group of a student. Okay, let's try. Tunggu sebentar. Sorry for the technical problem. I cannot wait for a while. Okay, so this is the example just now. So we need to calculate the mean and the midterms, the standard deviation of the midterms mark. So if you look here, so frequency is your F, midpoint, Fm is calculated. So now we need to calculate our M square first. So 2.5 times 2.5 is 6.25. Then 7.5 times 7.5 will be 56.25. Then 12.5 times 12.5 is 156.25. Okay, so this is the M square. Then after that, we need to calculate our frequency times M square. Frequency times n square. So the first one 6, 6 ni, 6 tambah ni. So 6, sorry, bukan tambah, darab. 6 times 6.25. 6.25, 37.5. Then add times 56.25, 450. Then 6 times 156.25, 937.5. So the total will be 450 plus 37.5, 1425. Okay, 1425. So to calculate our mean, will be sum of Fm divided by n. So sum of Fm is 150 divided by total frequency is 20. So 150 divided by 20, 7.5. Okay, 7.5. Then to calculate our standard deviation, the formula is sum of Fm square minus sum of Fm in bracket square divided by n divided by 1. So square root. So equals to sum of Fm square 1425 minus Fm in bracket 150 square divided by n 20 minus 1. So 150 times 150 is 22,500 divided by 20. So it will give 1425. 1425 minus 1125 divided by 19. So 1425 minus 1125 is 300 divided by 19 is 15.79. Square will give 3.97. So this is your answer for standard deviation. So I have another example here. I think you can try to do it. Okay, saya nak kamu semua buat. Try to calculate the mean and the standard deviation for this example. Alright. You can pause the video while you try to calculate. Okay, relationship between dispersion and standard deviation. So if you look, there is two line graph here. One is the C1, another one is the C2. So both of this graph is normally distributed. Okay, normally distributed, normal distribution. But if you look at the difference between C1 and C2, C2 is more dispersed. Okay, more dispersed because if you look at the point here, is more further from the mean. Okay, mean is in the middle. Mean, median, mode is in the middle. And C1, the highest here is closer to the mean. Okay, kerawakan data untuk C2 ni lebih luas berbanding C1. So C1 will have small standard deviation. Smaller standard deviation means most of the data is closer to the mean compared to C2. Most of the data is further from the mean. Okay, dia jauh daripada mean. Is far from the mean, sorry. Okay, is far from the mean. So this is the relationship. So in statistics, usually if you want to look at the accuracy of one data set, you need to make sure that the data has smaller standard deviation. Smaller standard deviation will give a good consistent data. Okay, compared to the larger standard deviation, your data is more widely spread. Okay, widely spread. So standard deviation is a measure of variation in the data. you may consider, you may wondering what is really is and how it relates to the data. It is a kind of yardstick by which we can compare the variability of one dataset with that another. So just want to add in, standard deviation is also used to look at the reliability of the data. Okay, after you gather your data, you want to analyze, standard deviation can show you the reliability of the data. So here another example. Okay, another example. So calculate the mean and the standard deviation of the set of data below. So set A and set B. I want you to try to calculate, then I will get back to these questions during our week 3. Okay, so try to calculate our mean and standard deviation for set A and set B. Then we will discuss the questions below. Okay, we will discuss the questions below and we will proceed to coefficient of variation. Because coefficient of variation, the formula is standard deviation divided by mean times 100%. So you need to calculate the standard deviation and the mean. But why we need coefficient of variation? Okay, why we need coefficient of variation is from this exercise. So thank you everyone. I hope everyone will view this video and try to understand best. Those who having difficulty to understand uh, any of the parts from this video, you try to take notes and let me know. We can discuss in our online class later on. Thank you very much and hope to please do your best and stay safe.